Okay, so we looked at how to modify our premise diagrams for the assertion that our standard form categorical statement is true. What happens if our premise asserts that our standard form categorical statement is false? If I have a universal affirmative, and that's my premise diagram, all right, then when I add my circled X to make sure that the subject class of the premise diagram is true, I put it in the only area I can, which is the intersection. That is the area of the diagram that is both S and P. And I circle it to remind myself. But if my diagram is a diagram for it's false that all S are P, then it looks like this. And I've already put an X in area 1 to prevent all S or P from being true. So if this is my premise diagram for it's false that all S are P, S already has a member, so I don't have to do anything. When I have a universal negative, if I'm just in Boolean logic and I say no S or P, I don't know if there are any S's, I don't know if there are P's. What I do know is there's nothing that is in the S and the P circle. There's nothing that's an S and a P. So that area is shaded. When I switch to Boolean logic for this negative universal, then I say S has to have at least one member in that premise diagram. So I put an X in the only area I can, area 1, and I circle it to remind myself I only am entitled to that X because of the Aristotelian assumption. But what is my diagram going to look like if my premise says that no S or P is false? Well, there, right, I look at my no S or P and I say, okay, well, to make that universal negative true, the intersection between S and P would have to be empty. So to make it false, I'll just put something in there. So I'll put an X in the intersection there, and that's how I get it's false that no S or P. If that's my premise diagram, then S has a member, so I don't have to modify my premise diagram at all. What about some S or P? Well, if I'm in Boolean logic, I said there's at least one thing. It's in the S circle. It's also in the P circle. So it goes in that intersection area between S and P. If I say it's false that some S or P, then I say, well, I can't have anything in that intersection. I have to make sure that can't happen so that some S or P are false. And that means I shade that area in. And that's what my premise diagram would look for Boolean logic. Now, if this is the premise diagram, I have to switch to Aristotelian logic. I look at that premise diagram, I look at the subject class, and I say to myself, hey, there isn't a member in that subject class, so I put one in, and I circle it to remind myself I'm only entitled to that under that Aristotelian assumption, like so. When I have a particular negative in Boolean logic, and it's my premise diagram, I said there's at least one thing. It's an S. It cannot be in P. It's outside of P. So it has to go in that area 1. So I put it in there. If my premise says it's false that some S or P, then I say, okay, well, there can't be anything in area 1. That would make some S or P true, or not be true. So I shade that area. Now it's impossible for some S or not P to be true, and hence it's false that some S or not P. That's my premise diagram, and I'm switching to Aristotelian logic. I look at that subject class, and I say, okay, it doesn't have any members. I can't put anything in area 1, so I have to put it in area 2, or sorry, 3, and I circle it to remind myself I'm only entitled to that under that Aristotelian assumption. So now we can see how our diagrams for the assertion that each of our standard form categorical statements are true look like. And we can see, for instance, why the subalternation relationship holds. Because now, if my universal negative is true, then there is a member in the S class, and that's all I need to make some S or not P true. I'll leave it to you to figure out why the other relationships are necessarily true. What about my effective decision procedure to test direct inferences for validity or invalidity in both Boolean and Aristotelian logic? Well, I'm always going to start off testing in Boolean logic. And the reason why is that both Boolean and Aristotelian logic have that contradictory relation. So if it's a valid argument in Boolean logic, it's valid in both our logics. And so if I find it to be valid when I test it in Boolean, I stop and I write valid both logics. However, if it's not valid in Boolean, if it's invalid in Boolean, then I've got to modify my diagram and test for Aristotelian validity. Because I'm a good logician, I'm clever, and I'm lazy, I don't worry about that conclusion diagram at all. I only worry about the premise diagram. I only worry about the class that's going to make a difference, that subject class. And I check and see, does that subject class have a member? If it has a member, then I don't do anything. I leave it alone. If it doesn't have a member, then I go to the area where it can go, and I put that X in, and I circle it to remind myself I'm only entitled to that because of the Aristotelian assumption. Then I'll check my diagrams again. Here's what I need to make my conclusion true. Here's in my premise diagram the way the world has to be when my premises are true. Does making my premises true give me everything I need to make my conclusion true? If it does, the argument is valid. If it doesn't, the argument is invalid. But because of the Aristotelian assumption, I have one last thing I have to do before I'm done. And that last thing is to check and see if that subject class in my premise diagram in fact has a member. Is it a real Aristotelian class? If it's not, if it's Pegasi or if it's leprechauns, then it commits the existential fallacy. So instead of writing valid in Aristotelian logic, I'll write existential fallacy. If it's a good Aristotelian class, then I'll write valid in Aristotelian logic. So in the next video, we'll go through a couple of examples of direct inferences testing for Boolean and Aristotelian logic so that you can see a couple of examples of how it's done.